Okay. All right. So let's see. All right. So welcome, scholars. We are at the end of week, 14, right? So let's do a brief synopsis of the remaining schedule of events, right? So today we'll go through as much homework pertaining to the last of the new material as possible, right? So section 6.4, systems of equations in two variables. We'll go through as much of that homework as we can. Next week, we meet on Monday alone, right? On Monday. So after this week, we're only going to meet 3 more times. We'll meet this upcoming Monday, where we will review exam 1 in preparation for the final. That Wednesday is a holiday. The school closes at noon, so we're not going to meet that Wednesday. We'll enjoy our Thanksgiving break. Then the following week, on the 28th, is that Monday. We're going to meet. We'll review exam 2 on that day. And then the 30th, November 30th, is the last day of class. We will review exam 3 on that day. So after November 30th, you're not obligated to be here. That Thursday and Friday is the reading period. And then your final should become available on that Sunday, December 4th at 11:11 a.m. and is due that Friday, December 9th at 11:59 p.m. That's the hard deadline. So that means that whatever work you've been doing, it's all due on that Friday, December 9th at 11:59 p.m. If you are going back and redoing your old assignments to improve your overall grade, my recommendation is to prioritize your exam 2, where that's where you're going to get the most bang for your buck. And you want to prioritize the homework last, because the homework is going to be a whole lot of work for little to no points. You're not going to see your grades shift. So even though the last day of class is November 30th, more than likely I'll just log on and just make myself available during our regular meeting times on Monday and Wednesday during the week of finals. So that way, if you have any questions, you know how to find me, right? If you don't have questions, you got all your stuff submitted. The last official day of class is the 30th, and you'll have access to whatever you need to have access to. And again, I just have to reiterate that Friday, December 9th is a hard deadline. So, the final exam is due at that time, and everything else is also due at that time as well. We can't push anything past that date, because from there, I have to calculate grades and submit final grades. All right. We're in a position right now, though, where anybody can get whatever grade they want. Like if you want a decent grade, like a B or a low A or whatever, you can even get an A, to be honest. Anybody can still get a B or A. You just have to devise a plan and take action, right? Everything is still available. You get unlimited attempts at all assignments. There's only a 10% late penalty. So, I've kind of given you a plan where if you are going back or trying to get caught up or whatever, prioritize your exams first. That's like almost 80% of your overall grade. And then, second, you want to prioritize the quizzes, and then last, you want to do that homework. Right. And I think there are prerequisites where you have to pass the quizzes in order to access the exam. So that kind of takes care of itself. Another thing for you all, because this has a lab component. Hopefully, you've been collaborating with Dr. Lamar. You should be able to see your lab grade on Blackboard, and all I'm going to do is whatever grade you see there, I'm going to take it and scale it to 10% of your overall grade. For us, I'm just going to calculate the grade like normal. So usually what I do, like exams, I usually do exams are 20% each, right? I think that's right. 3 times 2 is 6. Yeah, exams are 20% each, and then homework is 10%, quizzes are 10%, finals 20%. So whatever score you get there, I'm going to say times 0.9, because that's 90% of your overall grade. Then I'm going to take the lab component and say times 0.1, because that's 10% of your overall grade, and then add those two results together. Okay, so that seems like it's not showing. So let me see if I hop here if that changes. Let me check on you guys in Zoom, because I know we were missing a good amount of people. Okay, that's fine. Let me get these guys. Let's see. That looks like it is not showing. So let me just stop the broadcast and rebroadcast it. Start the broadcast. All right, so we just went through like announcements, and so this is being live streamed to YouTube, so you can always go back and you can listen to the intro. Come on. All right, it looks like it's working. So basically, I'm monitoring the stream to see if it's displaying, but it doesn't seem to be displaying, so that's why I'm hesitating. Let's see, what else could I do? Because I don't think you guys can see my screen. All right. I hate to do that, but I might have to if it's not showing. I don't understand why it does this. And it hasn't done this all day. Let me stop this share. Let me close this out. This is the right one, right? 3 p.m. Yeah. Okay, I'll be right back. All right, let's see. I think that's my next note. Yeah, that's okay. This guy. Okay, that's fine. Let me share my screen. Hopefully it'll work this time. And then let's go here. Okay, looks like it's working now. Yeah, sometimes when it's not working, I just have to reboot it. Allow. And I guess by the time I get to you all, it's just like, please reboot me. This one. All right, so then we're working here. This is the 3 p.m. It's looking like it's doing that freezing thing again. 6.4, come on. I need you to work. Okay. I don't know if you guys can see my screen. I'm still trying to, wait, it looks like it's working. Okay. Okay. So I'm gonna do one other thing. There's only one more thing I need. Yeah, I don't know why the equipment is being temperamental. It's been like this for the past week or so. And it's like it's not for any real good reason. Okay. Let's see. Okay, it looks like it's working. Okay, I'm gonna go with it. I'm gonna assume it's working because I kind of see it over there. Okay. But yeah, usually the reboot resolves that matter. Let me check on you guys' Zoom one more time. Okay, that's fine. Get these guys. This one is here. Okay, that's fine. All right, I think we're ready to rock and roll. Okay. So again, we went through the announcement. So you'd have to watch the live stream. Just go back and you can hear the things that I announced. So today what we're going through as many homework questions from section 6.4 as we can. Systems of equations in two variables. This question asks us which of the ordered pairs is a solution of the given system, right? So I think we could solve the system. I'm just going to plug and chug. So for instance, for part A, when x is -3, so that's going to be 6 plus 2 is 8. That checks out. -9 plus 4, it does not work in equation 2. Let's try B. That's going to be 12 plus 3. That doesn't work in the first equation. That's going to be an 8 plus 0 is 8. So that works. So C works in equation 1. -12 plus 0 is -12, right? So C works in equation 1 and in equation 2. So we're going to go with that. Okay. Next question. All right. Let me see. So okay, I think we're okay then. That's fine. So which of the ordered pairs are solutions of the following system of equations? So for something like this, I feel like it's better to just go ahead and solve the system, right? So let me get a copy. Let me get a copy of this guy. And with the latest update in Apple, I kind of like the latest update that they've done. It's still a little bit trippy, but I just like it, right? So watch, if I hit done, I can hit copy and delete. So that way I'm not having a whole bunch of like random screenshots of this kind of stuff in my photo library. There we go. And so now I can just paste the image that I want, and I'm not saving a whole bunch of like random images. Okay. So we're gonna solve the system. I feel like solving the system might be easiest with the elimination method. So let me start by getting a copy of the original. So then we have this, we have 5x minus 2y equals 7. We have -10x plus 5y equals 11. If we're going to use the elimination method, the goal there is to choose a variable, whichever variable you choose to eliminate, you want it to have the same coefficients with opposite signs, right? So I'm going to multiply equation 1 by 2 across the entire row. Okay. So that's going to give us 10x minus 4y equals 14. Equation 2 just comes down. Okay. And then when we add these two equations together, let's see. A number plus its opposite adds to 0. Negative 4 plus 5 is 1. 25, right? So then we get that y equals 25. So then if y is 25, we just need to plug this into one of the equations. I feel like equation 1 is a little bit easier to work with. So I'm going to plug this into equation 1. So then we get 5x minus 2 times 25 equals 7. What is that, 50? So then we get 5x equals 57. Okay. So then we're getting x equals 57 over 5. Okay. So then the ordered pair that we're getting we're getting 57 over 5, comma 25, right? And I don't think that that was one of the solutions. Okay, so if we hop back to Pearson, it's none of those options, so we're going to choose D, none of these. Right? Otherwise, we would have just been plugging and chugging and guessing and checking, and then we probably would have second guessed ourselves as opposed to just go ahead and solve the system and then extract it, right? But the solution was not in that list. Okay. Solve the system by graphing. Okay. So let's see. So if we're going to graph this, we're going to click here. Now, what I found works easiest. Notice that the highest exponent on any variable is a 1, so both of these are lines. So I'm just going to plot 2 lines at random, and then come back and edit them. Now, from the first equation, if we solve for y, we get x plus 2. So that means our y-intercept is 2. Okay. If we get x plus 2, that means the slope is 1. So then the next point is going to be 1, 3. Okay, so that's the first equation. The second one, if we solve for y, we get negative x plus 4. So the y-intercept is 4. And if it's negative x, that means the slope is negative 1. So we'll be at 1, 3 is the second point. Okay. And then if we hit save, it looks like they cross at 1, 3. Okay, if we did that properly, let me hit check. Okay, so then our claim is that 1, 3 is the solution to the system, and we can check it before we submit it. Notice that 1 minus 3 is negative 2, 1 plus 3 is 4. So then turn this off. So then 1, 3 should be the solution to the system. 1, 3. Okay. Let's go on to the next question. Graphical method. Okay, so they're asking us to graph. Let me see. There was something I wanted to do. That's fine. All right, so cool. Mr. Greenmack, are you progressing okay? Are you okay? Are you able to make your way through the assignments and do what you need to do?
Yes, I am.
Do you have like a tutor, or are you working with your classmates at all?
No, I just I would use the what is it called? The like get help at the bottom, like look at, here's an example if I
Okay.
like don't really understand something.
That's fine. So if you're just trying to get caught up, you definitely want to try to prioritize the exams. You get unlimited attempts, right?
Mm-hmm.
So it's not going to hurt you. It's just that each time you take the exam, it's going to change. You could work on it now if you wanted, and then if you had questions, we can talk about it, or I can just keep doing this. You know,
Yes.
but it's whatever you want to do. I also just want to bring to your attention that you have tutors, right? So you can also take this information and work with them. But I guess I'll just keep going.
Okay.
So they're asking us to do this one by graphing. So I'm going to click to enlarge the graph. And I'm going to do the same thing. I'm just going to plot two random lines, right? Because I think we're working with two lines, okay? So then I'm going to drag the points to where they need to be. So from the first equation, the y-intercept is 12. So I'm going to put my first point I'm going to drag this first point to 12. And then the slope is -4. So if we go down 4, we should be at 1, 8. Okay, so that should be the graph of that line. Oh, I think they're the same, right? So 12, 8, all right? So one equation, these are exact, these two are the exact same. So I'm gonna hit check. Okay. And then, so basically one equation is a multiple of the other. So that means we'll have infinitely many solutions. And all solutions are going to take on the form -4x, x comma -4x plus 12, right? So no matter what x value you choose, the y coordinate is going to take on -4x plus 12, take on that form. Okay. All right. Determine whether the following system is, thank you, stop. The system is consistent or inconsistent. If the system is consistent, determine whether the equation are dependent or independent. Do not solve, right? So in order for it to be inconsistent, you would have to have parallel lines with different y-intercepts. These lines are not parallel, so there is not inconsistent. So that means the system is consistent. And then in order for it to be dependent, one equation would have to be a multiple of the other. And one equation in this case is not a multiple of the other. So that means that the system is consistent and the equations are independent. Okay. Same thing here. So now notice if we say equation 1 times 3, we get our 9x, we get our 15y, and we get 21, right? So because one equation is a multiple of the other, that means the system is consistent and the equations are dependent. Okay. Same thing here. Now notice, if we multiply equation 1 by 2, we get our 12x, we get our -14y, but we don't get 33. So because when we go to solve the system, all our variables are going to cancel and we're going to finish with the false statement. That means we're working with parallel lines with different y-intercepts. So that means the system is inconsistent. I guess she doesn't like inconsistent systems. Solve the following system by the substitution method. Let me see. Okay, that's fine. Let's get a copy and take some notes. Thank you. Stop, please. Okay, we're going to take that, allow the paste. All right. Like that. Okay. All right. So if we're doing substitution method, with the substitution method, we solve for one variable in one equation and then plug that result into the other equation. So we were fortunate that they already solved for y for us in equation 2, so we can take that and plug it into equation 1. So then if we do that, we'll get 2x, come on, 2x minus 9 times y, but y is 3x plus 9 equals 69. So now at this point, we have one equation, one unknown we can solve. Okay. So we distribute the -9. Okay. We get 2x. What is that? 27 minus 27x minus 81 equals 69. So then we get what? Negative 25x. If you add 81, 14. So 140, 150. Hey, it's okay. Do you need to go out there? I know you're distracted. I need you to just chill. So if we divide both sides by negative 25, we get what? -6. So x equals -6. Okay. So then if x is -6, that means that y is going to be 3 times -6 plus 9, -18 plus 9, -9. Okay. So then our claim is that the solution or the ordered pair is going to be -6, -9. Okay. Stop. Just for the sake of time, I'm not going to plug this in to check. I'm just going to submit it in Pearson. If my pooch is like, stop. I need you to relax. You're making it hard on yourself. Okay. -6, -9. So we got A. Parentheses, come on. Parentheses, -6, come on. Okay. Let's go to the next question. Substitution method. Okay, so this is kind of a repeat of what we just did. Let's get a screenshot. And let's take some notes. Done. Copy and delete. Right here. No, stop. Okay. Substitution method? Okay, that's fine. I need you to relax. So if we're going to do substitution method, to me, it looks like it's easier to solve for y in equation 1. So from equation 1, we get that y equals x minus 2. So then if we plug this in equation 2, we get 9x plus our 7, our y is x minus 2, -78, okay? So at this point, we have one equation, one unknown we can solve. We get 9x plus 7x minus 14 equals -78. 14, 15, 16. So then we get 16x equals, if we add, we get a negative, that's a 464. Okay. So then x equals negative, what's that, 5, 4, 4, right? 40 plus 24. Okay, so then if this is our x, then that means that y equals -4 minus 2, which is -6. Okay. So then our solution, -4, -6. And I'm just going to submit this in Pearson instead of checking it. Oh, there you go. Ooh, I don't know if I'm fast enough. Thank you. Cool. Awesome sauce. All right, let me bring back up my image. Stop. Oh, it's crazy. This one. This one. Okay. So we got -4 and -6, and you get a chill. This one, we got A. I don't need you losing your mind. You act like you don't have no mind, so you can't follow instructions. I'll follow them for you. Right? Yeah, like you don't have no sense. Okay, solve the system by substitution. Let's knock it out. Screenshot. You're gonna have to wait. Done. Copy and delete. Allow. Okay. So it's a substitution method, right? Okay. So it looks like it's easiest to solve from y in equation 1. So from equation 1, we get y equals 4x minus 7. Okay. So then if we plug this in equation 2, we get 8x minus 2 times y is going to be 4x minus 7 equals 10. Okay. Same kind of deal, just same as before, just with different numbers. Right. So then we get 8x minus 8x. Oh, duh. Okay. So notice that equation 1 is almost a multiple of equation. Equation 2 is almost a multiple of equation 1. If we multiply by 2, we get our 8, we get our negative 2y, but we don't get 14, right? So that means that the system is inconsistent. We don't have to go any further. So it's the empty set. Substitution, okay, so this is an example of a nonlinear system of equations. But we essentially do the same thing. We're not really doing anything that different. We're just adjusting for the changes. Okay, I think this is going to be the last one. We might do one more after this one. Okay. Substitution method, right? Okay. So if we solve from y from equation 1, we get y equals, what is it, x minus 1. If we plug this in equation 2, stop. You're going to have to wait. We get x squared minus x times y minus y squared equals -5. So basically, I just replace all the y's with the x minus 1. So now I'm going to expand. We can distribute this negative x and expand that other guy. Okay. We get x squared minus x squared plus x. If we expand that binomial, we get x squared minus 2x plus 1 equals -5. We can distribute this negative. Okay. And a number plus its opposite adds to 0. So then we have x minus x squared plus 2x minus 1 equals -5. I'm going to move everything to the right-hand side. Okay. If we do that, we're going to get x squared minus 3x. So if we add 1, we're going to get what? -4 equals 0. I moved everything to the right-hand side and combine like terms. So then from here, we should be able to factor it to form like this, where we have x and x. It should be a plus and a minus. I think it's -4 and +1. Notice that -4 times 1 is -4, so that checks out. -4 plus 1 is -3, so that checks out. Okay. So then ultimately we get x equals -1 and 4. Then we need to go back and find the corresponding y's. So we have y equals x minus 1. Okay. So then when x is -1, the corresponding y, it's like it's -2. And when x is 4, the corresponding y is 3. Okay. So then we get -1, -2, and we also get 4, 3. Okay. This will be officially be our last one for the day. Okay, we got -1, -2, and then 4, 3. -1, -2. So parentheses, -1, -2, comma 4, 3. Okay. I'm gonna go with that. All right. Let me see the next question. Substitution method. Let me see. So notice, if we multiply equation 1 by -3, we get our -3x, we get our +12y, we get our -15. So that means that equation 2 is a multiple of equation 1. So that means that there are infinitely many solutions that take on the form. Now, if we solve for y, you're going to get x minus 5. So then 1/4 x minus 5/4. Okay. Let me check the next one. Okay, this one takes up a little bit of time, so we're going to go ahead and stop it here. Are there any questions that you guys want to ask? Any questions? I'm going to send a copy. I'm going to send a copy of everything that you saw me writing. I'm sending it to Box. When this bar finishes loading, you'll receive a copy of everything that you saw me writing. If there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. Take care. See you next time. Peace.